How you doing, Mr. Warrior? Man, I'm sorry that music in the background. It's just got me moving, you know? That beat. Yeah. Listen to it. Go. Anyway, come on. Yes, Mr. Warrior, let's get a little real here. Woohoo! Look at what we have here, my friends. It's a new feature animal of the week. It's a rhino. Look at that guy. Oh my goodness, what are you stepping in? Okay, I hope that's just mud, my friend. Hey, good to have you aboard, I guess. Yeah, you're pretty cool. All right, well, let's get down to why we're here, my friends. We're here because Mr. War has another math video. We have a learning target. We need to focus in on that because that's going to help us guide where are we going, you know? Because it's important that we understand what our purpose is. And this is our purpose. We are going to be multiplying, it looks like, a decimal fraction by single digit whole numbers. Okay, we're going to include the using of estimation to confirm the placement of the decimal point. And to confirm means, I don't know, should I write this down? The confirm actually has a meaning right here. Sometimes we're using these words in here, you know, we need to know what they mean. And confirm is really just to validate, means to like validate, make sure. All right? Kind of like when you check our work and we just confirm that it's true to see if it's true. Okay, my friends. Well, let's go ahead and get on down the slide. Go on down the slide. Woo. Okay, things moving like in slow motion. Okay, now it's down there. Let's take a look here. We have language frames. Those are always good, you know? Keep us from saying, well, like it's, you know, like, yeah. We teachers, we're not crazy about that kind of speech, and so we like when you use like a language frame. This is a nice one. My model shows my thinking because there's a nice common one that we could use all the time. We see why that's important because it sets us up for speaking in complete sentences. Yes. Who doesn't like to speak in complete sentences here? I know I do. Yes, I do. I really do. All right, let's move on to the next page. Dun, 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 dun. Oh, my goodness. Hi, Mr. War. I'm back. You are back. I'm back. Yeah, you're back. Okay, you know, that's fine. We'll let you hang out for a while, Rhino. Okay, just remember, this video is not all about you, Sir Rhino. Okay, it is about math. All right, let's go ahead and get started. So it's interesting what we have here. Look at these problems. My goodness, these problems, they look very similar, don't they? Yeah, they almost look like the same problem. I wonder how these three problems up here are alike. Oh, I see. Look at this. We have the same digits. We have a 3, a 1, and a 4. We could say that. There's actually a 0 there too. But we could actually leave that 0 out. But they are all part of these problems. And it's kind of interesting because even though there's the same digits, I wonder if they have the same quantity. I wonder how all of these products of all these three problems, if we were to solve them, how they would be alike. So let's go ahead and let's use an area model to solve. Okay, so I've set this up here where we have our area model for each one of these problems. Let's see what happens. Here we have 31 times 4. We've done this area model before. You may recall that the 31 has a 3 in the tens place, so we could say this is 3 tens here plus 1, 1. Kind of funny to say it that way, huh? 1, 1. Yeah. Okay. And then over here, we're multiplying it by 4. We put that 4 there. Now we can go ahead and determine what we have as our partial products. And that's referred as partial products because we're going to multiply, but it's not going to give us our final answer. Here we have 4 times 3, which is 12. Therefore, we have 12 tens. Yes. And here we just have 4 times 1, which is 4 ones. My goodness, it's kind of easy. I know. Now here we're going to write down, since we have 12 tens, we know 12 tens is equal to 120. And then we're going to add on that 4. And it's just 4 because it's just ones. We add that all together, we get 124. Isn't that beautiful? Let me take a picture. Okay, and we move on to the next one, Mr. Wara, please. Yes, so we have 3 and 1/10 times 4. Okay, similar, but it's not 31. Let's go ahead and set this up. Here with a 3, it's just a 3. We're just going to put our 3 ones right here. And we're going to add, ooh, he's in the tens place, so it's just going to be 1/10. Fair enough. We're still multiplying by that 4. That 4 is not changing. Notice that? Now when we multiply 4 times 3 ones, we're just going to get 12 ones. Okay. And then 4 times 1/10 give us 4 tenths. And then, of course, let's go ahead and represent this not in the written form, but in the standard form. So 12 ones is the same as 12. And then we'll add on, 4 tenths is 0.4, and then that's of course going to equal 12.4. Okay, We're good? Yes? All right, let's just keep it going here. Next one, we don't have any ones now. We just have 3/10. Looks like because that 3 is in the tenths place. Plus, and then we're going to add, this is kind of interesting because we have the 1, but it's in the hundredths place. So it's just going to be plus 1/100th. Now we're still multiplying by 4. There's my 4. Let's multiply this next. And then, of course, the 4 times the 100th. Key thing to remember that these are all, whenever we use that TH on the end, of course, we're talking about a quantity that's less than 1. Now let's go ahead and show 12 tenths. Well, we know there's 10 tenths in one whole. So it's just going to be 1.2 plus, and then we have our 4 hundredths, which looks just like money, 4 cents, right? Yeah, it looks very similar. Now I'm going to go ahead and put 1 point, and here I have my 2, and then my 4 in the hundredths place. Have to make sure. Be careful on that one here. You don't want to accidentally put like 0.06 or there we go. Now we're looking at these, and it's kind of interesting. I mean, we're looking at the digits here, and we notice that they all had a 3, a 1, and a 4. Now when we look at the products, you can see all the digits are 1, 2, and 4. And they're always in the exact same order. Notice that? They didn't change their order. I'm kind of wondering if these products have the same digits, and if those digits are in the same order, do the products have the same value? And when I'm thinking about that, I'm going to say no, okay? I'm going to say no because, see, these units here that we multiplied are different, okay? The units themselves. Like here we had 1/10, where here we have 1 whole. Here we have 1/100th, all right, which is less than 1/10. So even though the 1 was the same, all the value of each one of those units is different. So even though the digits are the same, where they're located, and especially in reference to the decimal point here, is crucial. So definitely we want to multiply, the numerals first, but then we think about the units to help us put the place value. This is what we did down here. So we just multiplied all the numerals, just the numbers first, and then we went ahead and dealt with that. Okay? Pretty nice, huh? All right, let's move on to the next page. Woohoo! Yeah. And it's a hidden page. Well, Johnny, what do we have behind curtain number 3? I don't know. Oh, yeah, you again, huh? Yeah, really? Thanks for letting me watch. You're funny. Yeah, you're a rhino. You are a cartoon character. Come on. Thanks for letting me watch. Okay, this is some serious personification here, wouldn't you agree? All right, I'm sorry, but the rhino, he's just kind of getting on my nerves a little bit because he's got that same look. So I'm. Oh, what's this? Ooh, a recycling center. Hey, Mr. Rhino. Yeah, I think I'm going to put you in this thing here. Sorry. Goodbye. What? Don't. Yes, yep. Oh, he's gone. Really? You think he's hiding behind it? I don't know. He's gone. Yes, Mr. War made his very first successful magic trick. All right. Yeah, we're going to go ahead and say you're gone. So can I just get rid of you? Yes, I think I can. Goodbye. Sorry, Rhino. See, I needed that room anyway. You were kind of blocking my little corner up here. All right, let's move on. Okay, I know some of you are thinking, Meanie, you're Mr. War, you're so mean. Well, hey. You know what? Got to do what you have to do. Let this math continue. Now we have, it looks like 5 1/10 times 6. Okay, well, let's go ahead and do 5 1/10. Now, wonder here, the smallest unit here is going to be the tenths place. Okay, I wonder if I could just go ahead and I want to convert this number into tenths. So I'm going to go ahead and multiply by 10 to put that into tenths. So if I took 5.1 times 10, that's going to equal 51. In this case, 51 tenths. Yeah, nice. Okay, now you can see that suppose our actual problem was 51 times 6. Because we've changed that into tenths. Let's go ahead and multiply that using the standard algorithm. Multiplying vertically. All right, so I'm going to set up my problem. I have 6. I have 30. I have 306. Now, we know that our product has these digits 306, right? But is this a reasonable answer to this problem up here? No, I would think not, right? Because we learned through estimation that if this is about 5, 5.1 is about 5, we know that 5 times 6, well, that would be more like 30, right? So since we had actually multiplied our factor by 10 in order to make sure that we get back, now we need to divide by 10. We're like doing the reverse. Tie your shoe, untie your shoe. Okay, we multiplied by 10, now we need to divide by 10. And by dividing by 10, one thing that happens when we divide by a power of 10 is the decimal place moves one place to the left. That's right. And that's when we divide by 10. Of course, if we're multiplying by 10, just the opposite happens. That decimal place moves one place to the right, which is what we did here when you think about it. That decimal place moved one place to the right. And this happens every single time we multiply by a power of 10. And of course, if we were to multiply by a power of 100, then of course it would move two decimal places because we'd have two powers of 10, 10 times 10, which I know you guys are really smart. You know that's 100. Okay, so let's go ahead and do that. So here's a decimal place, and then we're going to move it one place to the left. Now we have 30.6, and that does seem more reasonable with our estimation. Pretty cool? Yeah, yeah. All right, let's go to the next page. Ooh, it's another hidden page. You know what that? Oh, that rhino. Telling me that rhino better not be here. No! Oh yeah, huh? Me again? Yeah, right. Please don't throw me in the recycling container this time. I didn't throw you in the recycling container. I merely placed you carefully in the recycling center. Okay, you know what? I'm sorry, pal. See, now you're kind of getting on Mr. War's nerves here. It's time for you. No! Hey, easy, buddy. Just take it like a rhino, all right? Now, get inside there. Hey, what do you think you're doing? Oh, no. He found he figured out my pattern. He's not going to go in there now, is he? Look at that. Oh, man, he's got some kind of super force. All right, all right. You win. You can stay. Just please stay kind of out of the way here. All right, well, thank you. Yes. What's that? Mr. War, you're talking to a. Oh, yeah, I forgot. Thanks for bringing that to my attention. Yeah, Mr. War is speaking to like an inanimate object. Sorry, it just. Yeah. You know what? You look really tired. There you go. Yes, you're tired. Okay, fall asleep already. All right. Okay. Sorry. Yeah, okay, Mr. War, you really can be silly sometimes. Okay, let's get back on track. Now we have this 11 and 4 tenths times 4. So again, the smallest unit here looks like the tenths right here. All right, so what power of 10 would we have to use in order to get this into tenths? And okay, so let's go ahead and do what we did the last time. 11.4 times 10 means we get to move that decimal place one time. So that's going to give us 114. That's tenths. That's what we have. 114 tenths. Can't be hundredths because we didn't multiply by 100. We multiplied by 10. Now let's go ahead and do our algorithm like we did last time. Multiplying vertically. I have, looks like 16. Carry the 1. I have 4. I have 5. And then I have a 4. 456. Yeah. Oh, no. 456 would be way too large because look at 11 is about 10, right? Times 4 would equal 40. 456, that would not be reasonable based on our estimation. So, since we did multiply by 10, let's go ahead and divide by 10. Remember, that means we take the decimal place and we move it in one place value. And then we end up with 45.6, which is much closer to our estimation of 40. Okay, you having fun yet there, buddy? Hey, let me paint your nails here. There you go. Yeah, right on. Oh, major improvement. Okay, maybe a little tattoo? No, just kidding. Next page, please. Okay, again, now we have another problem, 7.8 times 3. Now I'm going to speed this up a little bit, right? Because we've had these samples. So 7.8, we want to go ahead and multiply by 10 right away, right? So we can get our 78 tenths. All right, I've taken the decimal place out. Let's go ahead and take 78 and multiply it by 3. Okay, 24, carry the 2, that's 21 plus 2 is 23. And we have 234 tenths. So that's right, I need to make sure that I divide by 10, get that decimal place in there. Is that reasonable? That's almost 8. 8 times 3, 24. Yeah, that's pretty close. And I like that. Let's go to the next page. Ooh, we have another one. 3 and 12 hundredths times 4. Well, for this one here, let's go ahead and do an area model since we have one already sitting here in front of us. I don't know where you came from, but okay, that's good. You're here. All right, so let's go ahead and do the same thing. Let's first, though, get that decimal place out. Let's do that. All right, so since we have hundreds here, we're going to need to multiply by 100 to move that decimal place because by 10 would bring it here, by 100 would bring it there. So if we have 3.12 times 100, okay, we're going to end up with 312. But remember, that's going to be hundredths, all right, because we multiplied by 100. 312 times 4. Well, we have 8, 4, and 12. So we multiplied our 2 and our 4, then our 1 and our 4, and then 3 and 4. All right, so we end up with 1,248. But remember, this is going to be hundreds. What I'm going to do here is I'm going to write like possible products for 3.12 times 4 on my board. And you tell me which one you think it might be. So I'm going to put way down here. Could it be 1.248? Or could it be, how about 124.8. No? Okay. How about the 1,248? We already figured out. 12.48. No? Oh, you're thinking it might be actually 0.1248? Yeah, they're also similar. All right, well, let's go ahead and do this. We're going to go ahead and do it based on this number here. Since we have three ones, we're going to put three ones. 1/10, we're adding all of those, and then we actually have two hundredths. Remember, these are our partial products. We're multiplying by 4. That means we're going to get 12 ones here. We're actually going to get, which could be 4/10. We're going to get 8 hundredths. We're good? Here we have 12 plus, remember 4/10 is 0.4 plus 8 hundredths, which is 0.08. Well, let's go ahead and add all those together. We have 12. Ooh, it looks like we're going to have a decimal point because we have 4 in the tenths place. And we have an 8 in the hundredths place. Aha! Who was the lucky winner? Looks like you were, my friend. Way to go. 12 and 48 hundredths. So even though we had taken the decimal out by multiplying by 100, in essence what we did was divide by 100 to put it back. Now it looks like we have another one, another example. Okay, so let's do that one more time. Let's go ahead and change this into hundredths. We're going to multiply by 100, right? That's going to give us our 322. The decimal place is moving twice. Now I'm going to go ahead and write our three ones for our area model. We're going to add, remember, 2/10. We're going to add 2 hundredths. Okay, we're multiplying by 5 this time. So now we have 5 times 3. That's 15 ones. Then we have 10. Looks like 10 tenths. And then we have, finally, we have 10 again, hundredths. A little different with this particular one because look what's happening here. Here we have 15 ones. Well, 15 ones, that's really just 15, right? So nothing. But now we have 10 tenths. And 10 tenths is the same as 1. So we're just going to add 1. Here we have 10 hundredths. Well, 10 hundredths is the same as, if you recall, that's the same as 1/10. So let's write that as 1/10. Now you can see we have 15 plus 1, which is 16. And then we have our 1/10. Should be 16.1. Oh, we didn't do our algorithm. So let's find out if that's true. 322 hundredths times 5. Well, it looks like 10, 10, and 11 carry the 1, 15, 16. And then if we have to divide by, remember, by 100 because we multiplied by 100 here, and we go 1, 2, and as you can see, we end up with 16.1. The 0, yeah, you can put as many of those on there as you want. Does not change the value of that decimal. Woohoo! Yeah! Now what I'm going to do in this one here, I'm going to go ahead and do this and just show you the answer here. It's okay, so go ahead. You might just want to hit pause. Practice this one on your own and see if you get the same answer I got. Last page here. Got one more problem, I guess. I don't know. Whoa! Oh, no! What is this? I'm back. I know, Mr. War, I'm still here. Please don't freak out. Okay. I won't freak out. Maybe I'll put you in the trash can, but there's no trash can to put you in. So you know what? I gave up. You win. I'm just going to shrink you down. Shrink, shrink, shrink. Okay, there you go. Yeah. So what we're going to do on this very last problem, we've done a lot of ones with the area model. So now what I'm going to go ahead and do and just do this one, multiplying by a power of 10. So that I can remove the decimal, and then I'm going to go ahead and solve the multiplication problem, and then we'll go ahead and go back. So here, when you see that decimal here, you can see that I have 1 power of 10, 2 powers of 10, 3 powers of 10. So that means I'm going to have to multiply by 1,000 to remove that decimal. So now I have 10,733 because I multiplied by 1,000. And I'm going to multiply that by 4. Let's go ahead and multiply that. Here we get 12, carry the 1, 12. That's 13, carry the 1. I have 28 plus 1, which is 29, carry the 2. Here I have 4 times 0, which is 0, which plus the 2 means I just get a 2 here. 4 times 1 is 4. Now, comma here. Now you can see by looking at this problem here, it's about 11. I would round this to 11 times 4, which would be 44 as an estimation. You can see that 42,932, in this case, which would be thousands. So what do we need to do? Well, with our number down here, and I'm just going to write all the digits. We need now to divide by 1,000. So if I do that 1, 2, 3 powers of 10, move that decimal to the left because I'm dividing. Now I end up with my 42.932. And that is the answer, my friend. Hey, hey, hey. You know what? That's it. This is the end of the video. So as I hear that wonderful, yeah, yeah, I'm not even going to music, but you know that wonderful beat? Like it? Yeah? Hey, my friends, live long and prosper.